Hello, my name is Han. Welcome to my channel. Today we're going to start a new series of tutorial videos. Let me check if my microphone is working properly. Yep. About development, of course, using Flutter, Rust, and C++. So the idea here is to make a simple mini project, which is going to look like this. It's essentially a transcription tool which allows you to either record some audio with your microphone. I'm using macOS, by the way, but something that should work on multiple platforms. So that's why we're going to use Flutter for the UI. So you can record a short audio file, or you can open a file that already exists. So I'm going to open a file because it's easier, and I have this little clip here. Then this tool is going to use the Whisper OpenAI Whisper engine to transcribe the text, the audio into some text, and the result should appear now in a minute. Hopefully, it won't take too long. Okay, there you go. So this is a clip from a newscast, and you can see that the text is here: other mass shooting in America, blah blah blah. Right? This one has also dialysis. I forgot the word exactly. Uh, which means that it can figure out that there's these different speakers and when the speaker changes. So this segment here is spoken by what's the anchor, I suppose, of the news. Yeah. It's a clip from TV news. So this is probably from the anchor, and then this part is spoken by the reporter on the field, and then there's some people that are interviewed, and so on and so forth. Right? Whenever you see speaker, it means that the person that's speaking has changed, and then you have a range which is like a timestamp range. All right, so or you can record something. Let me try recording something. So press record, and I say load the microphone. Let me record something. Stop. Okay, microphone. Let me record something. As you can see, it has transcribed my audio clip. All right, and then we have also history where you can see the stuff that has been transcribed. So this is what we want to build. Ideally, we want to build this so that it works on multiple platform, and we also want that it's not it's self-contained. It's not a front-end, back-end kind of app. So the audio that you're recording or that you're loading is not sent to a backend. It stays on your device, whether it's a phone or it's a computer here. We are not transmitting any of your audio to a server for processing. And processing has two advantages. First advantage is that your data is not leaving your computer, so you don't have potentially people eavesdropping on your audio. And second, it can be work offline. Of course, the disadvantage is that if your device is not very powerful, it would take some time to process, a long time to process. But that's not super important for the sake of this mini project. What else I wanted to say? I think that's pretty much it for the introduction. So how are we going to do that? I have done this stuff before. So you can go to my GitHub and you can clone the project as it is now. I'm still working on it, making some improvements left and right. But for this stuff, so far it's okay. So you can still do transcription and diatherization. I think that's the word. So this project is called Scribe, and it's a very small project. What it has, let's take a look at the structure. It's a Rust Flutter project. So when you clone this, okay, let's go on clone. Let's go on clone into a new directory. Oh, my oven is making a lot of noise. Right, so let me create directory tutorial. Go to tutorial and then clone this stuff. Okay, once you clone this, you have also to get the submodule. So I will say submodule update init and recursive. All right, that's silly because you have to obviously go to that scribe directory. So it's going to use Whisper, which is the OpenAI model for text to speech, no, speech to text recognition. It's a very powerful, very impressive model, by the way. So this guy here. The thing is that is it this guy? No, not at all. It's OpenAI Whisper. Whisper. All right, so this guy here. And so it's originally like most of this AI stuff. It's in Python and it's using PyTorch, the AI um, the AI framework um, for machine learning. So we could use that via source code, but since we don't want to have a backend, it would mean that we would have to embed a PyTorch environment inside our app, which is far from being trivial. And it would be also very difficult to have it portable and work on Windows, Mac, and mobile devices. So don't think it's easy way to do this. And fortunately, someone has made a C++ port. So the Whisper CPP is that same thing, but as a C++ project. And the beauty of it is this first line here. The key thing is that it does not have dependencies. So you're not going to bring Boost, you're not going to bring a lot of these C++ libraries that make integration interrupt very difficult. It's C++ is already not so easy to integrate. So it's really a good news that we don't have other dependencies. And of course, you also have all these things here, which makes this stuff very, very, very good. We have support for on macOS Apple Silicon, which is this kind of computer. This one is it's a Mac Air M1, so this falls under this category here. And technically, we could use the Accelerate framework, Meteor, and Core ML. On other platforms, if you're using x86, you could use the AVX Intrinsics. But the cool thing is really this part here. Fortunately, I haven't been able to make it work so far, but the fact that it's theoretically it's possible to integrate is very promising. All right, so the stuff that we have here, so this is a C++, this is a C++ library, which can use the same model that the model from Whisper. So a little bit of the architecture of this framework background is that if you compile this stuff, you also need the train model. We can try to make to train the models yourself, but it's probably much easier to download one of the existing models. So this comes with a bunch of pre-trained models of different sizes. Can go from base. Base is the smallest, I believe. I think this tiny. Yeah. It's tiny, small, base, medium, and large. So we're going to use the base one. It's a reasonable size for a device, even for a portable device. Okay, so but working with C++, even though it's easier than working with Python, like orders of magnitude easier, We even prefer to do is use Rust. Rust is not easier, but safer to use than C++, and it also has really good portability of capabilities. So moving forward, we have this library called Whisper OS, which provides bindings, Rust bindings, to the Whisper CPP, right? Rust bindings to this library is exactly what it's about. And with this guy, with this Whisper OS, we are able to write most of our code in Rust, with most of the backend code in Rust. So backend between codes, because this is the same app, right? We don't have technically we don't have a front end and a back end because the whole thing runs inside one process. But if we talk about separation of responsibility, the business logic, if you prefer, is going to be done in Rust with this C++ binding into the Whisper framework. All right, so let's take a look at how this Whisper OS works. So as Rust project, you see that it's a typical cargo guy, right? You have a cargo.toml. Well, I usually start from there because it gives me the structure of the project. You can see that we have a workspace that has one member. So this stuff is actually going to be annoying because toml projects cannot be done nested. So if we have a workspace here, and if we have a workspace ourselves in Scribe, they are not going to be. Yeah, I mean, yeah, I have here a toml, which is a workspace, right? And that guy here is going to be a workspace as well. So this is going to cause a problem because you cannot nest with workspaces. But that's a minor inconvenience. All right. So after that, we have definition of the package, license, documentation, nothing special. Then we have the dependency. So it says that this depends on the sys library, which is the path is here, sys. So we have a sys subdirectory, which is a subproject, and we are going to depend on that. And then we have a bunch of features. So features are essentially optional functions, features that you can enable or disable when you're using this library. By default, we don't have anything special, but you can activate CoreML, CUDA, OpenCL, stuff like that. And then that's pretty much it, right? So this you have Hound as well. Hound is a library for handling audio files. It allows you to convert from one format to another, and also resample if you don't have the right sampling frequency and add channel stuff like that. So the main thing is this Whispers. The reason why we have two libraries, we have this one here, and then we have a subdirectory sys. That typically what you have here, let me take a look, is that this is a pure Rust library, and this is going to be the interface to the users of Whisper. And this is going to be a pure, a very idiomatic Rust library. Right? You have the names are even like Rust-like, which is capitalized and in not camel case, what is them? You just capitalize class names. Then you what is it like this? I must have double clicked by accident. All right, so we have sys, and now we have source, and then you have you have then the definition of the interface. You have Whisper context, then Whisper params, Whisper state. Okay, so we're going to take a look at this later, but this just to show you that this part here is very clean Rust interface. Which the sys part is where you have the dirtier, or not dirtier, but the low level part where you have this is a Git submodule. So this essentially pulls the Whisper CPP project source code. So this is going to be exactly what Whisper.cpp is. So that's a clone of the original upstream C++ version of Whisper. So nothing is touched here. And then you have something that understands how to build this stuff, right? So normally a Rust project just needs a cargo.toml. The cargo.toml, very simplified one, has some predefined rules for where to find the source code, which one is the main source file, how to build a library and stuff like that, right? But obviously none of this stuff is going to make sense if you're trying to build a C++ library. So for this reason, the cargo build platform allows you to have customized build steps. You just have to you have to build to add a file called build.rs, which is a Rust file that is going to be executed as part of the build. For any time you have custom rules for building, then you can do that in build.rs. So build.rs is, as you can see, a bunch of are we on Apple? And are we okay? So this is we using CoreML, using CUDA, and then in response to that, it would add some libraries. We can add Blast, CUDA, and stuff. So don't really need to go to too much details, but this is basically where you will the Rust package will the Rust library will uh, execute. We know how to execute with what commands to build the C++ code. So typically what you have is that a bunch of definitions of variables, and then eventually you're actually going to call the build tool, the C++ build tool. So it could be a makefile, it could be Blaze, no, not Blaze. I don't know. Usually it's autoconf make. But if you have even better here, because you have a CMake, right? So if you this guy is using CMake, which means that we just need to set up the proper argument, the parameters for CMake, and then hats off to CMake, and the rest is done. Right? So we the only thing we had to do. Okay, so let's take a look. Let's try. Let's try by just cloning that. Just cloning that Whisper OS. So I already cloned this guy here, scribe. But why not clone this guy too? See how it goes if not we do nothing. Just clone this. We go to Whisper OS. Same thing. We have to update the sub modules. Right, and then we go and we do a cargo build, and then I do VV to be verbal so that I can see what's happening. You really don't need to do that if you're just building. This is to show what cargo is doing. Right. So for this part here, this is just normal dependency, so nothing was very specific. But now we're entering the part where we are doing CMake, right? So you can see that this is at the beginning here, nothing really special. Right, we're running this stuff, and now we're running the build OS. And the build OS is eventually calling into CMake, so we should have a CMake part. All right, so this is our real library. This is CMake, and CMake is running. Then it compares, it creates the makefile, and then it uses the makefile to actually build the CPP. And then at the end, well, it's done. And so that's this you really don't need to change this if you, for example, you have a bug in the platform. Actually had the support for Android was not working, so there is a change that I had to make. What was the change again? Well, so the guys who make this didn't didn't support Android. So if you go to WhisperOS, I forked the repository, and I changed the cargo in the sys directory. I must have changed something. Let's see the history. Commit update. That's not me. No, it's not even here. Is it here? This branch is 3 commits ahead. So I've done something. Android build. Alright, so I just added this. So what it does is that if you're compiling for Android, if your target OS is Android, then we have to specify the NDK toolchain. So this one is actually quite cool because CMake has the ability to build for Android as long as you provide the toolchain file. So all you had to do actually is to find where the toolchain file is in your NDK installation. For me, that was under this stuff here because I'm using the NDK 25.189 blah blah blah. Right? So that's the path for that Android toolchain.cmake. Once you have that, you also need to specify things like the Android API, which is whether you're building for 32 bits or 64 bits. And then this part here, which NDK platform, which is essentially the level of your Android, like level 31, 32, stuff like that. So this actually comes from I never compile directly using NDK. I use another tool called Cargo NDK, and the Cargo NDK is a extension to Cargo, which allows you to just do this Cargo NDK the and this will find the NDK for you and pass a proper flag. So with this and the change I made here, or I made here, the Whisper CPP and its binding to Rust can be compiled and can be installed. The result is a GNI library that can be used from Java or from Kotlin in Android. But if you're working on macOS, this really doesn't matter, and you can just use the default, the original, the unmodified build file. Okay. So what we have here is the Whisper RS integration. So if we want to build something, right, we are on tutorial. What we could do is just create another project. Let's call it okay, I have no name for it. Let's call it A. Okay. And then in A, we can go cargo new. Okay, it doesn't like that. Let me do it. Cargo new A. Right, we go to A, then we have a cargo file. You can see that it has created a skeleton for you. And this guy, we can add this folder to our workspace. Tutorial A. Okay, I trust this. All right, so what did it make for us? It made a very simple project file. Gonna remove this. Gonna change the name to Whisper tutorial. Okay, and then it also made my main file, which is going to say print hello world. So if I build this and I run it, cargo R, it's just going to say hello world. So first thing we want to do is add our dependency to Whisper RS. So to do that, I do Whisper RS, and I need to give the even the path. So I can do it as a path to the stuff I checked out, or I can. This guy has been published to cargo yeah, to the public repository. So to think that I can do Whisper RS as a cargo package. Let us see if it's on the crates, not crates, crates.cargo. Whisper RS 080, right? So if we want to do that, we just need to copy this package specification. Right, copy this guy here, and now we rebuild, and this rebuild will also bring all the dependencies. So this is more silent than the computation we made because we don't pass the dash VV, but you can see that it's also bringing the sys dependency, and behind the covers is also compiling the CPP, the C++ library. All right. So nothing should change because we didn't do anything. But now we can start using this from Rust. All right. So before we can use it from Rust, we should learn how to use it. And there's some example here. So let's copy this example, right? And if we copy this example, we should have something that, okay, the zigzag here, this doesn't look very good, but let's see why it's doing this. All right. No method for Whisper context in the current scope. Okay, that's really not good. Okay, this is actually a bug. They did not update the example. Yeah, bad people, bad people. All right, so that's give us an opportunity to actually um, take a look at how this should be done. To run model. You know what? Is it because it's state? Yeah, it's state. Somehow they use context and then they change everything to state. So I think this is the only stuff that we need to update. What else? Data param. What do data? Something's wrong here. Data params shouldn't be here. State shouldn't be here because we already state. So that's params. What is this guy here? Oh, it sometimes takes a while for IntelliSense to update. Right. So what we're saying is that this should be state. Okay. Man, it's gonna take a while. Yeah, now this is promising. It's a bit silly to have to do this. I'm sorry about that. It's already my fault. Um, but these things happen. Alright, so something only one error is remaining. Can both state as mutable? It's not declared immutable. Okay, so it has to be mutable. And perhaps it doesn't need to be mutable. Right. Alright. Fail to load model from path to model. So clearly here we have to change this. That means that we need to load the model, to get a model. So to get a model, I think the models are in cargo, not cargo, Whisper, CPP. And let's look at, let's try to download one of the models. Where are they? Is there something about models somewhere in the doc? Okay, here. Uh, for example, but okay, that sounds good. Did I find the path and models without? Maybe that should work. Okay, this guy here, right? And it says it's from models. We know that we have a copy of the source code of CPP here. The model should be here as well. And download GML, download. No, it's right here. Was not working. Download GML model. Okay. So let's download the base English one. Okay, and this is now here, right? GGML base. Let me move it to a place that is inside a more. Yeah, it's A. And then we go here. True works here, right? Okay. And then here, right, we have this guy. We can take the path to that. It's not going to create any issue with relative paths. And I'm just going to put it here. What's the name? This one here. Okay. Right. Then we can do calculate run. Okay, so it's loaded the module and it says U. Not sure it says U. Loading module, so this is so good. Where is the file? Audio data. Okay, this guy here is not really what we want. It recognizes you from absolute silence. I don't know why it found you, but what we want is to get the data from an audio file. So that requires a bit more work. So let's see if they have an example for that. Okay, basically use for more details. No, this is not very good. Okay, this one here. Alright, so this is the part where we can use the library to convert the audio file. So I'm going to use this code here, which allows me to open the wave. By the way, if things don't work immediately, this is also because I really haven't done this before. I mean, I have done something similar, but not exactly that. So where we are opening the wave reader to get the data from the audio file wave, but the reader doesn't actually read until you call something to read. So something is missing here. Hardware specification. Oh, here. Reader spec. No, want that. That. Where is the audio? Convert integer to float audio. Samples. Where are the samples? Okay, I think this is the do that. Right. Okay, so this is gonna read our file. So it goes to reader. It says that the samples are integer 16 bit integer, and yeah. So this will error if the wave is not integer 16 bit and it converts it to floating numbers. So then we can use that to feed into the audio guy, right? Only difference here is that it should be audio data, not audio. Yeah, so we have to choose is, well, we name this guy audio data. We should be okay, except that we don't have the file yet, but that's another story. Use, we don't have hound. So hound should be added to our dependencies. Hound, now, what version of hound? So we go to crates and we look for hound. Well, okay, here. 351. Okay, 351. All right. All right, so just, yeah, so there's no file. We can't find the file, obviously. This is annoying. Why would you do that? Mute. Yeah. So the rules here is that if something doesn't have to be mutable, we don't define it as mutable. Okay. We're missing the audio file. So the audio file, I have a sample one, which is the one from the clip. This is download. No. Okay, I have the audio as a MPEG, and I can use FFmpeg to convert it to audio wave. Audio sampling for SA 16K wave. What is AS or AR? Yeah, AR. Okay. And now I should be able to run it. All right, so that did it. So at this point, we know that we can. Okay, so we have our Rust integration into. We are using Whisper in Rust. Just like it's just a unit test, right? So far so good, but it's not the library. So what we do quickly now is well, we want to take this as a parameter, right? So we can turn it to the library by creating a lib file. So we can create a lib file here, and then say that we are publishing a function called transcribe, and it would take an audio file path as a string, and it should return a string. Right, and this our stuff here is essentially the same as here. So this is fairly quick and dirty, as you can see. You can imagine you don't really want to do production code like that. But for a tutorial, it's not too bad. Right, so we'll do it this way. And here we have, okay, so this is an error because the function does not return a string yet. So I'm going to put to do to get rid of that error. Then we have undefined references. So we can pick them up. There's 1, 2. Okay. Then obviously this guy here, well, you could take the path to the audio file. Normally you wouldn't want to recreate the whisper context every time because it seems to load the model. But as example, we're just gonna say context path, context. Yeah, we're gonna pass it as a parameter. And then you also should have the path of the file here. is what we want to also use the parameter here. The rest, okay, what is the problem for the rest? That the output is a line, print line to the console. What we want is to return it as a string. So we need to have a result string. So result string is going to be a mutable string or script, which starts as empty. And then we just append this stuff into it. Push string, and we want to push. Well, we want to push this string, right? So we want to push this string. We don't do a print and then we do a format now, and we're gonna say this is a line. Right, so this is going to be a string, and it's going to be a line here. Okay, and we just need to borrow the guy because this is a reference, so we need to pass. Then at the end, the conscript is going to be returned. Conscript. Okay. All right. Let's see. Seems to be okay. You should be able to compile this. At least compile. Okay. So our main now, we don't want to use this stuff. We want to use actually the stuff the path we still need. So I want to keep this path here. And then it's going to be audio file. So our main is going to be transcribe with the context. So I'm guessing this is actually running in the same directory. I think we don't need this whole path here. Let's try it like that. And audio wave. Okay. All right. This returns a string. Let's put the transcription file. And then we can print that guy out. So this should do the same thing. And then we do a counter run. All right. So, okay, we have the same thing except that the new lines are not working. And that's simply because when we do this line here, this is format, not format lines. So we manually have to add the carriage return. What? But this is odd. I'm sure it's happening. Into this keep thing? No way. Okay, I'm not sure why this is doing this. Format line. Okay, this makes no sense. Yeah, it's really weird. I don't know why it was not working before. Yeah, it is strange. Okay, I don't know. Maybe I didn't save. Interesting. Okay, so anyway, we have now a project that, okay, so the thing is, at this point, this is a library that is a Rust library, and you can see because if you go to the target directory, which has well, debug and release, but this is a debug build, you can see that the library that we made is rlib, which is Rust library. Even if we build for release, which is just bypassing the flag -r, we're still going to be a rlib, but it's going to be a release rlib. So what we need to do is have a section lib that tells us that we also want to create C libraries. And I kind of forgot the syntax for that. Let me Google it. Rust C. Okay, so this is guy here. Cargo friend. Cargo. Yeah. Okay, here. We should do create type, right? So we want to make this guy build create type cdlib. We also want rlib in the case, but we really want to cdlib. So let's call this guy. Right. So that now, if we go to target release, we also have this guy here, and the goal of the next video is to create C bindings so that we can use this library here. So this function, this function transcribe from Flutter, so that we can build our front end, our UI. So the UI would be like asking us for the audio file or recording the audio, and then calling this Rust function to actually do the transcription, and then we get the transcript, and then we can show the transcript to the user or record it into the database. So our next goal is to make this stuff usable as a from Dart as a C FFI, foreign function interface, using foreign function interface. Right. So, but that's enough for today, I think. We're basically halfway.